So my name is Donald Sumbry. Everyone that knows me just calls me by my last name, just calls me Sumbry. You can find me on Twitter as @Sumbry. A little trick that I use is if I have never met you or talked to you and you cold call me and you call me Donald, I will actually know that. I'm like, okay, I've never interacted with this person before, so just Sumbry. Today I'm the engineering, one of the engineering directors for Twilio. I've actually been at Twilio for about 4 years, and I've kind of done a variety of things over that time. In the very early days of Twilio, we probably only had about 30 employees. I was doing things like setting up the wireless, for example. However, today, I'm largely involved in the infrastructure and operations teams at Twilio, and that includes managing all of our Amazon infrastructure. Twilio is almost 100% on Amazon. We deploy infrastructure on AWS across the globe. We run thousands of hosts as well on Amazon, and my teams are sort of responsible for managing all of that infrastructure. And that, of course, includes setting up the virtual private cloud infrastructure and kind of coming up with a migration strategy for it. So, and is the clicker going to work? Uh-oh. All right. So I'm going to pass this off and just use the space bar for now. So what are the purposes of this talk, and what are we going to talk about today? So I'm going to start off by telling you just a little bit about Twilio and what we do. We're going to kind of review our legacy infrastructure, what Twilio had in the past. We'll talk a little bit about VPC and what's useful about it and why you should want to switch to it and start using it tomorrow. And then we'll also tell you about an internal project that we built called the Twilio Cloud. Thank you. Then I'm sure the part that you're all really, really interested in is we'll talk a little bit about how we actually migrated to VPC, the tools that we kind of developed to help do this, and then a lot of the lessons that we learned along the way. This talk is the second time I'm sort of giving this talk, except it's a bit expanded. I gave it last year, and a lot of the feedback that we got is we want more information. We'd like to know, how did you actually accomplish the migration? What are the tools that you actually use to do it? Really get into the weeds and the details. So I hope that we're going to do a great job of doing that this time. So with that said, let's start off what is Twilio? How many of you have actually heard of Twilio or use us today? Show of hands. Oh, wow, that's great. Awesome. I'd love to hear that. So just a quick primer, Twilio's a global communications company. We provide a real-time communications API. We're used by over 500,000 developers, all over the world. We have a really interesting requirement, and that is that we require sort of low latency resilient infrastructure. And what do I mean by that? So if you take a streaming video site, for example, if it takes 5 seconds to start streaming a video, it's probably not going to bother you that much. It's not that big of a deal. If it takes 5 seconds to initiate a phone call, you're going to hang up. So we've got this really interesting use case that not a lot of companies on the cloud have. And so we require that low latency and definitely resilient infrastructure. You always expect the dial tone to work, and that's what Twilio provides. And today, we have a lot of infrastructure that's on EC2-Classic. We've actually been an early user of Amazon since about 2008, and so we'll get into the details on that in a little bit. These are some of Twilio's customers, many that you've heard of. Everyone from Uber and Hulu to PayPal and Walmart. We got a nice shout out in the keynote today as well. That was awesome. So one quick thing that I want to point out about Twilio before I go any further, and this is a really interesting stat that our CEO actually pointed out at our annual Signal conference earlier in the year. If you count the number of phone numbers that Twilio has, we're actually the second largest carrier in the United States. So think about that for a second. Over 80% of the people in the US interact with Twilio, whether they realize it or not. So if you can imagine the infrastructure that's required to kind of support that and the tools and the technologies that we're building as a result of that, it's actually pretty impressive. So let's talk a little bit about Twilio, legacy Twilio, I like to call it. So again, we've used AWS since about 2008. Back then, we only had 3 products. We had a voice product, we had a conferencing product, and we had an SMS product, and that was pretty much it. All of our infrastructure was located in US East 1, like many companies back then. And we only had a few hundred instances. And basically, all of our instances were located in one giant shared subnet, which is the 10/8 in US East 1 that I'm sure a lot of you are familiar with. And then, of course, whenever we needed an elastic IP for something, we just provisioned one. We had lots of random, non-consecutive EIPs spread all over the place. Wow, I think this Never mind. So anyways, this is basically what Twilio's infrastructure looked like. Everything in sort of one giant USD Swan data center. So Twilio, about 3 years ago, we had an interesting requirement, and that is that we needed to go global. We had started off offering products in just the US, but we actually were moving into Europe, we were moving into other countries, and so our infrastructure had to actually follow suit as a result. So we had a bunch of new requirements that suddenly popped up, and we basically got a bunch of our engineering leaders together, and we sat down, and we really thought about this in great detail. We realized that we need the ability to provision resources globally. We need the ability for services in different locations to actually be able to talk to each other. We still needed that low latency communication, and especially if you think of doing something like routing a call. If I'm in Ireland and I need to talk to somebody in Virginia, we actually route that call internally over the Twilio network. So that's got to happen fast, and it's got to be resilient. And then now that we're deploying services all over the place, how do we actually find these services? How do I look up a voice routing service that's in Ireland if I'm in Virginia? These are sort of all problems that we realized that we had to solve as we started going global. So this is actually what our network looked like. Wow, this is kind of jumping forward on its own. This is actually what our network looked like after we went to global. And so there's a really interesting story behind this. You'll notice that the first pass of this, we actually used proxies. We wanted to use VPC very early on. However, it didn't have a lot of the features that we wanted. Even the first version of VPC didn't have internet gateways. There was no way to actually address traffic out on the internet. So while we wanted to use VPC and we saw a future in it, we realized we had to come up with our own solution. And so we came up with this proxy architecture. And we actually knew that we should not have done this, but it was the only way to really go forward and launch these products. Wow. All right. I think this thing has got a mind of its own today. That's all right. And so, we knew that, deploying proxy infrastructure, there was going to be a lot of problems with doing that. Single points of failure, if a proxy node goes out, what happens? Your applications have to be a little bit smarter with how they deal with that. Everything's sort of invisible on the other side of a proxy. If I send a request from USC1 to EUS1, I can't really see the instances that are behind that request. I'm just kind of throwing something over the wall and hoping that it sort of gets dealt with. And then proxies are also very, very slow, which is something we sort of knew, but we went ahead with this anyways. Looking back, it was definitely the right decision, because today Twilio, serves lots of different countries and we have infrastructure everywhere. However, it was definitely not ideal at the time. So what are some of the problems that we encountered when we initially went global? We had the overlapping 10/8 networks. So if I provision an instance in USC1 and one in EUS1, there was a chance that they might actually come up with the same IP address. So there was sort of no way for me to have those instances talk to each other without doing, natting or doing an overlay network or any number of sort of network tricks. Again, proxies weren't ideal for this use case. They're sort of point to point. So I couldn't do any intelligent routing or anything like that. There was no way to kind of route around failovers with this architecture. And again, proxies were slow, and we really needed, low latency communication. So why don't we actually, decide to adopt EC2-VPC? And so how many of you are, and this is a quick question, how many of you are currently on VPC right now? Okay, wow, that's a great number. How many of you still have infrastructure in Classic and are on VPC? Okay, as expected. So I'm not going to have to sell VPC too hard to most of you, but these are some of the features that were really attractive to us with VPC. And we internally at Twilio consider it basically EC2 2.0. It's the next major revision of Amazon's EC2 platform. It's got a lot of great new features. It performs better. There's no reason why anyone should be running infrastructure on Classic other than legacy reasons. And there's 3 key features that we really like about VPC that I'm going to talk about today. The first being, we have a software-defined network, we get elastic network interfaces, and we get HVM instances that support SR-IOV. So let's talk a little bit about that. So what's a software-defined network, and what are some of the attributes that we really like about it? Well, number one, it gives us the ability to define our own network. I can create subnets. I can create CIDR blocks. That's great. Also gives me the ability to have routing tables. This was something that was sorely lacking in sort of Classic. I couldn't really control routing to all of my instances unless I actually went on the instances themselves and used a bunch of IP tables, sort of hackery and things like that. I also get network access control lists now. So I can apply sort of these granular rules across my entire network if I want. If any of you have worked with sort of traditional networking hardware and firewalls, this basically looks like something that we've had for the past 10, 20 years. Another interesting attribute about SDN is that I can provision networks like virtual machines. So I'm actually a big fan of Ansible, and Ansible is actually really great at this. I can define a bunch of networks in a simple YAML file, run a command, and basically spin up and tear down VPCs in like a few seconds. It's awesome. And then another nice attribute of an SDN is, I get to protect my data in transit. I'm not sort of sending all my packets on this giant shared public cloud anymore. I've got my own little network that's segmented off. And in terms of compliance and things like that, that's actually a great attribute. So Elastic Network Interfaces, again, these are just sort of like EIPs a little bit evolved. I won't talk too much about these, but ENIs have a MAC address, which we really like. They have public and private IPs. We can take them and move them around to different instances, and the security groups, et cetera, actually follow along with the ENI. They're way more flexible than just Elastic IPs by themselves. And then, of course, my actual favorite, HVM instances. These are hardware virtualized machine instances. They basically give us an Intel extension that allows us almost physical access to the network card in a host. So this means that we can actually get almost 10 gigabit network speeds on instances. And there's a lot of performance stats that some other presenters have actually presented. That's great. The guys from Netflix, Pinterest as well, that basically confirms exactly what we've seen as well. 10 gigabits on a VM. That's awesome. So we've got all these nice features. So how does this actually solve the problems that we're running into? So why should we move to EC2-VPC? The SDN solves the overlapping 10/8 networking problem. The route table gets rid of our proxies that we had from before. Now, in terms of routing around failures, it's just a simple API call. And actually, if there's any Amazon product managers in the room, I have a feature request. I actually want the ability to be able to use multiple routes to the same destination that are weighted in my route tables. I'm hoping maybe something like that's coming in the future. If not, I'm just going to put that on the feature request backlog. And then, of course, using HVM instances, now it solves sort of our low latency problem. We basically get direct access to the NIC on a box, and it's extremely fast, and performance is extremely consistent. So let's talk about the Twilio Cloud, because this is basically what we took all these building blocks and we assembled what we internally called the Twilio Cloud. The Twilio Cloud is iteration 2.0 of Twilio's networking infrastructure. It addresses a lot of the limitations we ran into with Classic. It connects all of our different data centers together. Some of these data centers are not on Amazon, so this is great. Gives us automatic failover and redundancy, and like I just mentioned, it's provider agnostic. So what does the Twilio Cloud actually look like? And this is really just a subset of the cloud. But as you can see here in this example, I've got basically 3 data centers. One of the things you'll notice that each of these data centers is actually numbered slightly differently. I've got US East 1, which is 172.16. I've got US West 2, which is US East 1 is 172.16.1. US West 2 is 172.16.2, and then IE1 is 172.16.3. So again, one of those attributes of having a software-defined network is I can control my own network numbering, and now I have the ability to route traffic between all of these different regions. So let's talk about routing a little bit. What does that actually look like? In this example, we've actually got instances in US East 1 and instances in US West 2, and then we've actually got 6 routing instances, and they basically all connect to each other and form a giant mesh networks. The reason why we do this is sort of for redundancy and reliability. We actually run EIGRP IPsec tunnels between all of these routing instances, and they can fail over routes almost instantly. If we lose an instance, it's pretty much we might lose a couple of packets before traffic fails over to another route. So this is actually a really nice attribute that we get with using SDNs and using HVM instances and using routing on top of VPC. So we've got this great thing, the Twilio Cloud. We spent all this time and effort building it. We solved all these previous issues. We were really proud of ourselves and started patting ourselves on the back, but we ran into a big problem. And that was that none of our engineers used it. Everyone was completely happy with Classic. So we sat down and we started really thinking, well, why did this happen? Why doesn't anyone sort of want to jump onto VPC and jump under the Twilio Cloud and start using all these advanced features? And then we realized that there were two big problems. Sort of our VPC infrastructure and the Twilio Cloud, from a networking point of view, was completely separate from EC2-Classic. And there was not really a migration path for teams or services. How are they supposed to take their services and actually literally pick them up and move them over into this new infrastructure that we actually built? And I'm pretty sure this is a problem that most of you are running into today. You know, you've basically got Classic infrastructure, you've got VPC infrastructure. How do you move your services and your infrastructure from one to the other? And so we're going to focus on that a little bit in the second half of this talk. And that's why we really approach this as a data center migration. When I moved to the cloud, I thought I would never have to do this again. I remember the days of packing up a bunch of servers, throwing them in a truck, and driving to another data center, and taking a couple of hours outage while you're physically moving and plugging a bunch of infrastructure back in. But this is literally kind of exactly what we're doing with a a Classic to VPC migration. It's a data center migration. So why is it like that? Again, separate infrastructure. Except we have an interesting requirement now. We actually have to move everything with zero downtime. And we're basically picking up all of our compute infrastructure and moving it from one data center to the other. So to kind of illustrate what I'm talking about a little bit here, you can kind of see that I've drawn sort of our two distinct networks. We have the EC2-Classic network, and we have the EC2-VPC network. And we kind of have the different attributes of each. With the Classic network, again, we're still using proxies to kind of move traffic around. It's point to point. With the VPC network, we've got full mesh and routing. But if I want to get traffic from instance I AAA over to instance I GGG, how do I actually do that? Those networks aren't actually connected to each other. And so that's the big problem that we ran into. So what do we actually need to solve? So it's four big problems that we need to address in this migration. We need the ability to move an instance from Classic to VPC. We need network connectivity between Classic and VPC. We need the ability for instances to be able to actually discover each other. In my previous example, how does an instance in US East 1 find an instance in US West 1? And then we need the ability to be able to do this without any service interruptions. So again, Twilio, we provide dial tone, we provide communications infrastructure. It always has to work. So we need to be able to do this migration without any of our customers actually noticing. And so this is kind of how we thought about this in the beginning. And so very quickly, I'm going to talk a little bit about how Twilio works internally. Twilio is structured around what we call small teams, So small teams average 7 to 8 engineers. They actually own their own services. They even support those services in production. And these teams actually deploy their own services. And we use service-oriented architecture. So Twilio is actually composed of a lot of microservices. We did not call them microservices when I first started at Twilio, but apparently now they're microservices. And we have hundreds of these microservices. They all talk to each other over REST interfaces, more or less. And so if you're looking at how we thought about actually doing this migration, well, we've got all these services that are running in Classic. And in this example, maybe service A is a PHP application server. And service B is a database server. So thinking about how we do the migration is we basically launch a copy of all of our infrastructure in VPC. So now we basically have services running in Classic and services running in VPC at the same time. And then we'll just load balance requests across both of them. One question that I've actually gotten asked before is, well, what about latency? If you're now load balancing requests between Classic and VPC, isn't that going to make things slower? And what we actually did is we measured this. We launched a bunch of instances, and we basically measured the latency between Classic and VPC over ClassicLink, which I'll talk about in a little bit, over the public internet. And we said, OK, is it better or worse? And in fact, It's actually better. By launching instances into EC2-VPC, we actually saw slightly more consistent performance than just having instances solely in Classic. So there was a definite win there. So we've got infrastructure running in both Classic and VPC at the same time. And then, ideally, we then kill off all the instances or the services in Classic, and our migration would be done. However, in actuality, it's not that easy. So I just pointed out a bunch of things that we'll dive a little bit deeper into. And this is sort of the steps to migrate a service. So we need a way to bridge EC2 and Classic together. We need some concept of global service discovery. So services in Classic or VPC can actually find each other. We then need to basically deploy a service with this new knowledge, then deploy a copy of that service in VPC. So now we've got services running in both environments. And then move things like ELBs or DNS entries that basically pivot, pointing from Classic instances over to VPC instances, and then deprovision, all of our Classic instances once we're done. So what just happened? I think I just invented a bunch of things that I haven't really talked about. Bridge EC2-Classic and VPC. Well, how do we do that? Global service discovery. What's that? How do we do that? I've got to do multiple service deployments now. This means I'm going to have a lot of changes happening in my environments. Like, how do we actually do all of this? And this is where we're going to get to the meaty part of this discussion. So if you're paying attention or if you're falling asleep, it's the time to pay attention. So these are some of the migration tools that we actually developed to actually solve some of these problems. And what are the tools that we came up with for migrating to EC2-VPC? And there's a few of them. And Twilio's very big on sort of the Unix philosophy of small tools that you combine together to get lots of complex results. So what did we come up with? Prior to last year, before ClassicLink was announced, we actually built our own ClassicLink. And curious, how many people here are familiar with ClassicLink? OK, so ClassicLink, more or less, is a network bridge. That's all it is. It basically connects your network in an AWS region. ClassicLink basically connects a network in EC2-Classic in an AWS region to a VPC. So we actually built our own tool that did this initially, and then we dumped it in favor of ClassicLink, and that was a tool called IP Tunnel Manager. Another tool that we created is what we call global service discovery. We actually had our own internal service discovery system, and we just gave it an additional attribute that let it actually see services and instances globally. There's a concept of what we call distributed load balancing. I'll get into that in a little bit. And then another tool that we had called config renderer, which lets us render configuration information based on information that we get from service discovery. So I talked about quite a few things there, so let's actually jump into a little bit more detail. So again, what is IP Tunnel Manager? Crossed out because we deprecated that in favor of ClassicLink. ClassicLink allows us to link instances in EC2-Classic to a VPC in the same region. So in this example, we've got US East 1. I've got instances running in the sort of public cloud that's EC2-Classic. In this example, they're all numbered 10.0.1 through 3. Then I've also got instances in a VPC that I've created in the same AWS region. And I've been very careful when I created this VPC to not overlap the networks with the TIN network that's in Classic. And this is extremely important because if you have overlapping networks, ClassicLink does not work. So this is probably one of the most important things you should walk away from this talk with. It is extremely important to number your VPCs so they don't collide with any Classic subnets, and that you give yourself a lot of room to actually grow into these. Wow, I think this laptop is possessed. That's all right. So again, that's basically ClassicLink. So we built this ourselves. However, Amazon now provides this feature, and they've made this very, very easy for everyone else to do. I would actually like to take partial credit for ClassicLink because I've been hounding Amazon for something like this for years. And this is actually one of the key features that makes migrating from Classic to VPC easy. So number 2 is global service discovery. So Twilio, like I mentioned very early on, we had our own service discovery system. And so what's service discovery? This is getting a lot of, I don't want to say hype, but it's getting a lot of attention recently. Service discovery at a very simple level is just the ability to ask an agent for a piece of information, about your services. In our case, service discovery just provides IP addresses. So I can say, hey, I would like to know all of the IP addresses of my MySQL databases, and a proper service discovery system should just return me back a list of IPs. By enabling the sort of global attribute, we will not only get IPs that are in sort of Classic, but we will also get IPs that are in VPC as well. And the fact that we sort of have ClassicLink that's bridging both of these networks together, now I'll see instances in both Classic and VPC. So this is one of the most important attributes that we had to add to our service discovery system to sort of enable this use case. So distributed load balancing, and I'll take a little bit of time to actually talk about this because this is something core to Twilio and sort of how we work. This is a form of fault isolation for us, basically. Twilio very early on opted to not use what we refer to as centralized load balancers. So in a typical setup, you might have an application server, and it might need to talk to a bunch of MySQL slaves, right? You might put a load balancer in front of those MySQL slaves that load balances requests, to all of the slaves, and that's great, but now you sort of have a single point of failure. If that load balancer breaks or dies for whatever reason, now none of your application servers can actually talk to your databases. So Twilio, very early on, we said, what we're going to do is we're just going to put a load balancer on every single instance that we have in our cluster. And if that instance needs to talk to any downstream services, it's going to contact our service discovery system, say, give me a list of all the IPs of all the MySQL databases. It's going to actually take those IP addresses, put it in its local HA proxy configuration, restart every time there's a change, and then any applications running on the box will just talk to that local HA proxy instance. And that's sort of it. So distributed load balancing. Basically, we moved away from centralized load balancers, and we placed all the load balancers on the individual instances themselves. So now in this example, I've basically got an ELB, that's fronting like we'll call it our website. That ELB talks to two application servers that are actually in Classic. Those two application servers talk to their local HA proxy, which is getting updated with information from the service discovery agent. And they're actually load balancing traffic across the sort of bridge we have with ClassicLink to database servers that have actually already moved over to EC2-VPC. So this is what Twilio's network is actually starting to look like today with ClassicLink. We have started moving over some of our core services like databases while leaving things like application services in Classic. And the idea here is that as we sort of map out our dependencies and figure out which services need to go first, we will move those services over to VPC, and one by one over time, eventually we will end up in a state where everything has finally migrated over to VPC and we have nothing left in Classic. In reality, we're in the middle of this right now. So we're not done, and this is actually going to take a lot of work. It takes a lot of coordination with our service teams, a lot of coordination across all of engineering, and we have to be careful when we do this so that we don't cause any interruptions in service or break any functionality for any of our customers. So one of the other tools that I talked about is an agent we have called Config Renderer. Config Renderer is actually pretty slick. All Config Renderer does is it actually renders our HA proxy configurations, and it does this with information that it gets from the service discovery agent. So in this example, I actually pulled this from one of our Git repos. You see that at the top, we're actually telling, we've actually templatized and said, I want to get a list of all the web services and assign them to the instances array. And then later on at the bottom, we actually use that and we say, loop through this array and basically just add all those IPs as a list of servers that we're going to actually load balance requests to. And that's it. So Twilio's got a bunch of configuration files like this that control all of our HA proxy configs. Anytime we bring up a new host, that host gets added to the service discovery system. The service discovery system kicks Config Renderer and says re-render this HA proxy template, or this HA proxy config. That file gets re-rendered, HA proxy gets restarted on that instance, and now you're load balancing requests to the new instance that we just booted up. This actually works really well. This is definitely an attribute of something that we've built, but there's actually a lot of open source tools that do things like this today. If you're starting out on a project like this, do not write your own service discovery system, please. There are like 30 of them out there already. Some of them are good, some of them are bad, but you should take the time to actually do the research, because in another couple of years, I kind of feel like we're going to standardize on service discovery systems. One of the biggest service discovery systems in the world is DNS. Works great. It's central to the internet. I kind of feel like we've got all these open source products doing this now, but sort of the same thing is going to happen, so don't reinvent the wheel. And then the last thing I'm going to quickly cover is just deploying services. We have our own internal provisioning tool that we call boxconfig. It makes it really, really easy for us to deploy a new version of a service. In this instance, we're actually just booting up a host and just attaching a role to it. We also have a concept of booting up a group, which is just a collection of hosts, and attaching roles to them. When I mentioned that engineering teams do their own deployments at Twilio, this is the tool of choice that they actually manage their deployments with. So being able to easily redeploy your services over and over is another attribute that's going to make migrating to VPC sort of very easy. So I've talked about all these things. How does it all work? How do we actually all put this together? And again, Unix philosophy. Let's use lots of small tools and combine them all together to get really complex and interesting results. So we use the Twilio Cloud and ClassicLink to route traffic. Sorry, we use the Twilio Cloud to route traffic. We use ClassicLink to bridge traffic in the same region. We use HA proxy for distributed load balancing. We use global service discovery to get IP information and distribute that to hosts. We use config renderer to actually write out HA proxy configurations. And then we use our internal provisioning tool, boxconfig, to actually manage the deployments and let us deploy services over and over. So, in conclusion, where are we actually today? And I will be completely honest with this slide. The Twilio Cloud is live, so we've got this giant network connecting all our data centers together. It routes traffic through 9 virtual data centers. It has over 100 IPsec links, and we sort of get automatic region failover thanks to EIGRP. About 30 to 35% of Twilio infrastructure actually lives in VPC today. So some of our core services have already moved. All of our new services are being deployed in VPC from day one. If you put a gun to my head and said, Sumbri, you need to complete the VPC migration by the end of the year, we could do it. In actuality, ClassicLink has actually made us lazy. ClassicLink works so well that there's actually not a reason to sort of rush this migration. If you've ever sat in on some of the really interesting VPC talks, like a life of a billion packets, et cetera, they actually kind of describe how the VPC infrastructure works. ClassicLink is literally just an extension of VPC. So it's going to work forever. There's not really a rush to kind of migrate things over. And so we can really take our time with this. But if you put a gun to my head, yeah, we could probably move everything by the end of the year. So what are kind of some of the lessons that we learned during this whole process? And I keep repeating this one because it's extremely important. Make sure to properly subnet your VPC. You've got one shot. We recently discovered that we actually messed this rule up ourselves, and we have a collision in one of our networks. And so now we're going to actually have to go through a lot of pain to fix this. Please don't repeat our mistakes. Make sure, sit down with your network engineers or architects. If you don't have any, bring in a consultant. This is so extremely important to get right. You've got one shot. It's much like cabling, servers in a data center. If you mess it up, that stuff's live. You're kind of stuck with it forever. There's not a reason to do a giant migration all at once. You can take your time. You don't have to rush through this. But one thing I will point out is it's extremely important to understand all of your service dependencies so you can kind of figure out the sequencing. How do you actually move? What goes first? What goes last? What's safe to kind of hold off on? Extremely important. This next one is also important. Your tools have to work both ways. You may mess up, you may discover that maybe something works differently in VPC than it does in Classic, and you need the ability to roll back. Make sure everything that you build and you design can work both ways. You can do a migration from Classic to VPC or VPC to Classic. And avoid complexity. Less complexity always wins. Don't try to over-engineer how you're going to do this. ClassicLink makes a lot of things very easy, so simple solutions to all of these problems. And that is going to be it. And so we've got a little bit of time for questions.